Good morning, sir. Good morning, everyone. So, today our team is going to present Clip Scholar. It is nothing but leveraging LLMs for AI driven educational content generation. So, these are my group members.
Bharat.
I am Gnanesh.
I'm Gopal.
I am Madan.
And I'm Nachiket. So let's look at the contents. There's introduction, the system architecture, the architecture of the LLM that we are using. Then there's data flow for the three features that we are adding into our web application, which is nodes generation, flashcards, and quiz. And then you have the integration with the AWS, which is a cloud service. So let's look at the introduction. Now, as you know that today's tempo has shifted from long span videos to small reels. For example, you have YouTube reels, you have Instagram reels, and you have all those things. So the attention span of people, especially the students, has reduced a lot, and hence it students find it very difficult to watch long videos at length or even educational videos for that matter. So that is why we are proposing this solution, Clip Scholar. What it does is it takes your video and it produces a summary of it. So its benefits are it saves time, it improves clarity, and it's quick searchability because you can skip through a lot of videos, including what is there in that, not just scroll them using your banner, but actually scroll the content and see what is actually there inside and select the videos that are there, and then you perhaps watch them or research on those contents. And now let's look at the system architecture. So you have the user connecting the front end through HTML, CSS, and JavaScript. For the backend, we have used Flask, which is based on Python. And then there's the Superdata API. So what we are using is we are throwing the YouTube URL to the Superdata API. It will generate the transcript through the captions that are available in the video, and this transcript will feed it to Mistral. Now this is an open source LLM that's available. We are accessing it through an API key, and then it will return the summary in form of JSON, which we are passing, and we are producing your notes. And from notes, again, we are refeeding them into Mistral to produce the two more extra features that we said, which was quiz and flashcards. And for quiz, we also have the evaluation. All right, now let's look at the architecture of Mistral. That's the open source LLM that we are using. So as you can see, the inputs are first converted into embeddings. Embeddings are nothing but vector representation of your inputs in the vector space. And then you have the RMS normalization. Now, normalization is basically done so as to equalize the influence of all the variables across the weights, so that no one particular weight does not have too much difference with the another weight. That is why normalization used. And here we are using the root mean square normalization. Followed by we have something known as self attention. It has two types here, that is grouped query attention and the sliding window attention. So what they do, they are just a type of attention. Now attention mechanism, it is a mechanism that allows the transformers to focus on those parts that are important, and reduce those parts, or neglect those parts which are less important. So that is how the self attention vector works, self attention mechanism works. Then you have again the followed RMS normalization, and then you have a feed forward block. Now this particular process, it is repeated for n times. As you can see, there's an n cross here, which means it's repeated for n times. So you're continuously feeding it, because at first you will just have random vectors. So when it is continuously learning, those things get better and better. Same as what we are when we are training a model. As your accuracy increases when you are training again and again, because it is learning the features. The same way here, the attention mechanism learns on which parts to focus and which to ignore, which is why we are doing it for n times. And then again we have an RMS normalization, followed by a linear block, which is just to reduce the number of tokens. And finally, we have the softmax layer. Now, softmax layer, as we know, it is mainly used for classification, showing the probabilities of different classes that are present, which is what is there, the output probabilities. So this is what I had explained, the final RMS normalization and linear and softmax. Now let's look at the data flow diagrams for the three features that we are offering. First is the node generation. So as I said, we are passing the YouTube URL, extracting the video ID, which will be passed to the API, and it will produce the transcript based on the video caption. And this will throw it as a prompt through Mistral instruct large. This is the model that we are using, and then it will generate nodes in JSON format and will pass it. Then let's look at the for flashcard generation. The data flow is will throw in the prompt as generated nodes along with the difficulty, which has two, three difficulties and the number of flashcards. So it will produce the flashcards using the again JSON format and then we'll pass it. Next, we have for quiz generation, we are using the generated nodes along with the quiz type, difficulty, and number of questions. So quiz type, we are offering three. That's MCQ, fill in the blanks, and short answer questions. Again, as a prompt. And then we'll have the quiz in JSON format. Evaluation will be done based on the answers given at the time of question generation only. We'll have the answers also. So we'll evaluate it based on those answers. Now let's look at AWS. So it is hosted on AWS EC2, which is a cloud website. So we can access it anywhere on the internet, right? So we are using Gunicon, which is a Python HTTP server for running the web applications written in Flask, right? So that's it. Thank you. Now I'll be showing the live running of our website. So as I said, it's published on AWS EC2 instance. So this is my EC2 instance, and this is the public IP address that they have given us. So we'll just copy this and let's go to it. And we have launched at port 80, which is the default port for HTTP. So this is we are using Gunicon, and this is the local address hosted at 80th port. So we'll just go there. So this is the website. We'll just go here, and now the rest of the part will be explained by Mother. Thank you.
Now we will be moving forward with the demonstration of our platform, Clip Scholar. For demonstration purpose, we choose this YouTube video which is of length 51 minutes. We'll paste the link, click generate. It will take few seconds to generate. As you can see, this is the video that we chose, and this is the corresponding structured notes of that video. The video is about multi-data attention from scratch, so it has code also in its notes, key points, examples, detailed explanation, and also it has the references where it takes the notes and the recently processed video history. You can also download the notes. Now next feature we will go with flashcards generation. For flashcards we need to give two parameters. One is number of flashcards, another is difficulty level, easy, medium, hard. We'll go with the default values. Click generate. This is the generated flashcard. This is a question, and the corresponding answer will be a backside of it, Flipkart. See, it has generated 10 flashcards, limitation of self-admission, embedding matrix, so on. Now either we can go back to notes or go to quiz. I will go to quiz section. Quiz section has three parameters. One is quiz type, number of questions, and difficulty level. You can choose. First we'll go with multiple questions, multiple choice. Number of questions 10, difficulty level mixed. We will enable the timer also. Generate quiz. We will randomly know the answer for demonstration purpose. Now you can automatically evaluate your answers. My score is 5 out of 10. You can also download your results. Now we will try with another quiz type. This time we will try Q&S, question and answers. In this case, you need to type the answer. As of now, I'll give next. Submit answer. I only answered 1 out of 10 questions. Okay. See my answer and the correct answer. You'll get the whole answer key. This is the quiz section. Now we'll go back to the home page and the history will be restored. As you can see, the video's length is about 15 minutes. We spend just 15 to 20 minutes. We'll completely gain this concept crisp and clear. This makes our platform out of the box and extremely useful for the students and learners. And that's it. Thank you.